Hi, I'm Andrew, also known as Eduardo. You might remember me from such short-lived YouTube profiles as Eduardo Igarisu numbers 1 through 5. I'm now Eduardo Igarisu number 6. And this is a response to what Brian Leake has been putting out lately about spherical excess and the transcontinental triangulation in American Arc of the Parallel survey. He had a video a few days ago called Spherical Excess Demolished Part 3. And he also presented some of this stuff on a live stream on Flatzoid's Perspective called Discord Debate Evening on the 2nd of March. And he's also drawn upon a presentation that I did on Flatzoid's channel as well on the 19th of February. Links are in the descriptions for all three videos. Brian has been presenting this image, which is based off page 62 of the Transcontinental Triangulation. These are the first triangles presented in the book, and he is just looking at the first 5 of those and noting that 3 of them have a deficit of angle, whereas all triangles on a spherical surface should have an excess of angle. Well, I'm going to do a bit more analysis, and let's see where it takes us. So this is page 62, and I'm just going to zoom in a bit and explain some of the data that I'm taking. In the green box is triangle 1 of the Kent Island basenet, and the first thing that is shown is the observed angles, and the 3 of those add up to 180 degrees, 0 minutes, and 1.29 arc seconds. So that's an excess of angle. And it's just noted as the 1.29 as the final part of the angle. The rest is assumed to be 180. Now, each of those angles that make up that have corrections applied to them, and that is in box B. As you can see, minus 0.59, minus 0.31, and minus 0.15, totaling up to C, minus 1.05. And if we apply that correction of minus 1.05 to the initial angle of 1.29, we get D, which is 0.24. which is shorthand for 180 degrees, 0 minutes, and 0.24 seconds. The triangle below, number 2, starts off with 59.83, which means that is actually 179 degrees, 59 minutes, and 59.83 arc seconds. And the corrections are applied to that, and it ends up with 0.45, which is short for 180, 0.45. So an excess after all those corrections. I've taken the data from 4 of the base nets for a total of 81 triangles. I stopped there because it's quite an effort to copy all these numbers into a spreadsheet. But let's focus just on the 12 triangles of the Kent Island base net. So here is the data from the Kent Island base net put into a spreadsheet. Note that it is only the numbers in bold that have been input by me, copied from the book. Everything else then is calculated from that. We see that we have column A is the original observed final part of the angles. The 3 column Bs are the 3 corrections that are applied to each of the 3 angles in the triangle, which sum up to C. That's the total correction for the triangle. And when that total correction of C is applied to A, we get the corrected amount of excess. It's taken straight from the book. I've also done some error checking to make sure I didn't put the data in wrong, and then the rest of this over on the right hand side is some analysis of it, which is summarised up the top of the page. Now I'm going to have a little bit of a look at where the corrections come from. I'm not going to go deeply into how they're calculated, but the important thing to know is the corrections aren't done directly onto the triangles, they're actually done onto the observations done at each of the survey stations. So we're now looking at the observations that were originally made at the Kent Island North Base survey location. They started by pointing directly at the Kent Island South Base and called that the 0 degree direction. They then swung around 50 degrees to see Marriott, 38 more to see Taylor, another 33 to see Linstead, and another 60 degrees to see Swan Point. Now these angles between each of the targets they were looking at became the corner angles of the triangles that would be later assembled. Now again, without going into detail, the result of the correction equations was that a small amount of adjustment needed to be made to the directions that they thought that they saw their targets. For example, their direction to Kent Island South Base needed to be moved clockwise by 0.19 arc seconds. Their direction to Marriott needed to be reduced anti-clockwise by 0.47 arc seconds, and so on for the rest of the observations from that location. Now, note that the total of all the numbers in the red box is actually 0. So they didn't add any angles to their observation, they just shuffled around the amount of angle they moved between one and the next. So now let's look at how this plays out in one of the triangles of the Kent Island basenet. So here represented in green is the angle that was measured by standing at North Base and looking at South Base, and then turning across and looking at Marriott. And as you can see, it is the same 50, 05, 05.36 that we saw on the previous page. Now, To that, we have to add the corrections. If we see on the previous page, the direction to Kent Island South Base needs to be moved clockwise by 0.19 arc seconds, and the direction to Marriott needs to be moved anti-clockwise by 0.47 arc seconds. So let's do that. And here we have it represented in red. The direction to South Base has moved clockwise by 0.19 arc seconds, and the direction to Marriott has moved anti-clockwise by 0.47 arc seconds. So it has resulted in a reduction of the overall angle of 0.66 arc seconds, from 50.05, 05.36 down to 50.05, 04.70. And we can see that here when they constructed the triangle. Number 4 there, we have our original angle in green, 50.05, 05.36. We have the two corrections totaling negative 0.66, giving us a final angle of 50.05, 04.70. So let's see what happens when all those corrections are applied to an entire base net. Over on Kent Island, there were 12 triangles in the network, and 6 of them started out with an excess and 6 of them started out with a deficit. For the entire network, there was 9.5 arc seconds of excess. And if that was to be averaged out over all those triangles, you would have about 0.8 arc seconds of excess on every triangle. Now, the result of all those corrections is the overall excess in the network was reduced by 0.12 arc seconds. So very, very little. So it went from 9.5 to 9.38 and averaged out over all the triangles. It went from 0.792 to 0.782. So not really much change in there. Now, it's interesting to note that with an average excess of about 0.8, each of the triangles actually was adjusted on average by about 1.4. So it was adjusted by almost twice as much of the amount of excess that was in each triangle. So you might be wondering, well, maybe something's going on there. But in fact, it is just how the correction equations work. Sometimes there are large corrections, sometimes there are small ones. We'll look at another one of the base nets and see that it can sometimes work out the other way. So here on the YOLO base net, the average excess per triangle was about 5.4 arc seconds, but the corrections only applied a change of about 0.68 arc seconds. So they're actually only moved by about 13% of their average magnitude. So in this case, the corrections were really quite small compared to the magnitude of the excess. So there's nothing funny going on here. It's just a consequence of the correction equations that some networks will experience relatively large correction amounts and some will experience relatively small ones. So, some concluding remarks. For Brian to focus on just the first triangles in the entire book and cry foul because 3 of those 5 happen to have a deficit is ignoring quite a few things. Firstly, he's ignoring the remaining 7 triangles in the Kent Island base net. Now, he's ignoring also that the average excess of the triangles in that base net was 0.8 arc seconds, and that the margin of error of observation is what's caused some of them to show a small deficit. He ignored the base net corrections, which are just a statistical averaging of the locations of the observation sites within the network, and he ignored all the other networks in the entire survey. There were a total of 21 networks in the survey that comprised 308 surveying sites, from which 743 triangles were assembled. And here he is just focusing on 3 out of the first 5. And some of those networks, before even having corrections applied to them, had no triangles with any deficit at all. So, why did Brian not bother to investigate any further? Well, as Blue Marble Science so wisely commented, he can't be troubled to do something like that when he already has the cherry he was looking for. So, thanks for watching. See ya.